Okay, so let's get started. Today we're going to look at comparing and ordering rational numbers. What is a rational number? Again, you're talking while I'm talking. That's very rude. Stop it. Figure it out. Okay. So rational number is any number that can be written as a fraction, a over b, but b is not 0. Now a and b are integers. So we're looking at things like -4, +7. As a fraction, we'll be looking at 3, which becomes 3 over what? 1. So any whole number can be written as a fraction, 3 over 1. -4 would become -4 over 1. And so those, since they can be written as fractions, are what we call rational numbers. You can also have decimals, like 0.24. You can have decimals that repeat. 0.3 repeating with the repeat bar. Okay. You can also just have fractions like 3/4. What about 2/3? That works. What's 2/3 as a decimal? Top divided by bottom, 2 divided by 3. Good, so it repeats forever, so it's a rational number. Oh, just a second, my calculator says 7, so I guess it doesn't repeat, it changes? No? Yeah, be smarter than your calculator. The calculator rounded it. Try that right now on your calculators, see what it does. You're going to need your calculators out, so get it out and try it. So let's continue. Some examples of irrational numbers. Now we looked at some irrational numbers yesterday. Those would be like pi, okay, √2, √3. But a rational number would be like √16, which equals 4, because we can then go to a whole number. So there's some radicals that can be simplified and some can't, and those are what we call irrational. Okay. So when we're comparing rational numbers, when we're comparing decimals and fractions and whole numbers, we can do a couple different things. First of all, the easiest way is put them into decimals. So if we have 3 over 4, that equals 3 divided by 4. And what does your calculator say? .75. So the decimal 0.75 can be compared to another decimal. And a lot of you want to do that. I suggest you do that unless I say to find equivalent fractions. So if we have 2/5 and 3/4, we want to get a common denominator of 20. We have to find equivalent fractions. So multiply this one by what? What do we multiply 5 by to become 20? 4. Then we have to do that to the top as well, and we get 8. Okay, so these guys are what we call equivalent fractions. What about the 4? What 4 times what equals 20? 5. And so we get 15. And so we can clearly see that 3/4 is larger than 2/5 because 15 is larger than 8. So you would just compare the numerators. Okay. Good. Say we had 2 over 7. What would be another equivalent fraction? Well, it's real simple. Times it by 2, and we get 4 over 14. Those are equivalent fractions. Or you could times them both by 3, and what would be another equivalent fraction? 6 over 21. Okay, so they have, all 3 of those have the same value. Refreshing your grade 6 memories. It's been a while. Okay, Google equivalent fractions. If you need some help, Google equivalent fractions, please. Okay. Good. Now the other method is the half method. If we have 2 over 5, Half of 5 will be 2.5. Okay. Don't use an equal sign there. Now, and so what we are notice that we are less than halfway. We're less than 2.5. If we have 3 over 4, what's half of the fraction? 2 over 4, right? Half of 4 is 2. So this one would be more than a half. So because it's more than a half, we know that this would be larger. It's not for accuracy, but it gives you a good idea if you have two fractions there. Okay. Any questions? A lot of a review, but a lot of kind of old reviews. So if you do have questions, you do need to ask, okay, so we can help you out. Negatives. Two things to think about is that the larger the digits, the smaller the value. So if we have -3 and -3.2, this one here is smaller because it's closer to -4. It's further from 0. The thermometer, if you use a thermometer, it can help you a little bit. Okay? So you may want to plot the number on a number line, a vertical one. Fraction, or the other idea is that the opposite values are the same distance from 0. Okay, so let's look at that with our fractions. Opposites are equal, they are both equal distance from 0. So let's do the first one, 7 over 12. What is that? Well, as a decimal, it's 0.583. Repeating. So we know that's going to be, if this is halfway, it's going to be slightly bigger than halfway. So when we're doing our negatives, we will find -1/2. Now we have to do the mirror image. So since 7 over 12, it goes 0.5, 7 over 12, it'll do the same thing on the other side. 0, -0.5, -7 over 12. So now I plotted -7 over 12 on the correct side of -1/2. Okay. What about 2/3? What is that as a decimal? We've done it once already. 0.6 repeating. Or -0.6 repeating. So 0.6 is going to be a bit larger. Notice how I write the original question. Always do that. And on the other side, I should have the same order. 0.5, 7 over 12, 2/3. So 0, -0.5, -7 over 12, 2/3. So you want to make sure you can use the mirror to help you plot on the correct side of the lines. Any questions? Negatives are tricky. Just really work on them. So now I want you to take these ones. The easiest thing is to go to a decimal. So quickly find a decimal and put it in the right spot. But don't put, put the original question. So does it belong here? Is that where -1.5 is? No, it's on the wrong side. It must be in between. So use the other digits to help you place it. And I just wrote the wrong number. I'm supposed to write the original. Okay. Plot the other two right now. Put them in decimal format. Plot them on the number line, please. person beside you right now, so you can do the same. Yeah. Okay, so negative 3.5. That's going to be right here, in between negative 3 and negative 4. And negative 5/1/8 is going to be a little bit closer to negative 1. It should not be in the middle. If it's in the middle, Mr. Barker does what? Marks it wrong. Okay. Pac-Man, trying to be funny. I make the jokes. Okay, next one. Put the following numbers on a number line. Be aware of halfway. So use halfway as a reference guide. What do you think you want to do with those fractions? Yeah, you can put them into a decimal. Or divide it up into fives. So 1, 2, 3, 4, 5. And 4/5 would be right there. Okay, go ahead for B. Okay, so let's have a look up here. So we should go CB close together, but they are not halfway. They're a little bit closer to negative 2. Then we have A pretty close to 1, E a little bit to the right of a half, and D should be right there between 2 and 3. Any questions? Yes, Cassidy.
Oh, E. I was wondering how it would like go there.
Oh, because it should be. Duh. Where's A? A is 4/5. E is going to be right here. Thank you. I was in the wrong spot. Well, good check. Well done, Cassidy. And others. Okay, moving on. Number 3, turn it over. So remember with the calculator, it's 3 divided by 17. Convert it to a decimal, and then you can compare the two numbers. Write down 4 decimals. So which one do you think is bigger? The one that's closer to the next value. Okay. Now B, you gotta be careful because you have negatives. So with the negatives, just convert your fraction to a decimal. 6 divided by 7 is 0.857. And don't forget about the negative 2, which is a whole number. So it just goes in front of your decimal. Okay. Now, which one is larger? Negative 2.8888. Nope, because that one is closer to negative 3. So it's actually smaller. So we should circle the first one. Okay. Now, do we have to worry about the negative 2 at all? Not really, because both of them had negative 2. What we're really concerned about is the decimals. So sometimes you can ignore that number in front and just focus on the decimal values. Okay, go ahead, C and D, go for it. Compare them, turn them into the decimals, and compare. Okay, so we have 4.8, 4.6. This one's larger, it's closer to the number 5. Okay. Here we have 1 divided by 6, which is negative 3.1666 repeated. So this one here is closer to negative 3. So this one is actually larger. All right. Now we don't have to worry about the negative 3. We could just compare the decimals. We could simply compare 0.2, negative 0.2, and negative 0.166 repeated. Okay, so sometimes when you have the same number as a whole number, just compare the decimal values. And you'll see that question come up in your textbook. Any questions? Yep.
I was just for negative. Do you want to go
Yeah, because then like a thermometer, you're going to be higher, okay? And that's the weird part, right? It's negatives throw you off all the time. It's very common. Okay. For this section, now I'm extremely specific. I say find equivalent fractions. So you need to get a common denominator. Okay, get a common denominator. So with 5 and 10, what's the common denominator? 10. Okay. So this is 3 over 10. It's not going to change. But what do we have to multiply the first fraction by to get 10 in the bottom? 2. And to keep it equivalent, we must multiply the top by the same number. So we have 4 over 10. Now compare the numerators. Compare the tops. Which one's bigger? 4. And so we circle the original question. Sometimes, like B, you have two numbers that are, so you have two numbers and neither of them are the common denominator. So what you need to do is find it. This trick always works. Multiplying by the opposites always works. Okay, go ahead, find them. Okay, so the trick always works, timesing by the other denominator. So we get negative 9 over 15, negative 10 over 15. Which one's closer to 0? 9. Yes, the 9. Sorry, negative 9. Okay, so circle the first one. Okay, go ahead, do the next two. Go. Okay. Yeah, so don't, here, we just need a common denominator of 35. We don't even have to look at the negative 2. Sorry? Oh, thanks.
Do we have to put 77 into like, do we have to turn negative 2 into negative 2? So it's like over 35?
No, just leave it. Yeah. Yeah. Okay, so the larger digits is 77, which means it's smaller. So this here is going to be whatchamacallit, the bigger number. Yeah, the one closest to 0. So I got 10 things on my mind here. Okay, next one. Go ahead. How do you get 3.16 as a fraction? Little review for you. Pay attention. If I had 0.3, that is the 10th decimal value. So to convert it to a fraction, it's simply 3 over 10. It's that easy. Write it down, please. If you have 0.17, the value of the 7, the last digit, is hundredths. So what do you think our pattern is going to be? 17 over? Good. And we can continue. 0.31311. That's going to be the thousandths value. So then what will that be as a fraction? 311 over 1,000. So you got to know your place value of your decimals. It helps you turn into fractions. And what's the cheater method? How many decimals? How many zeros?
1.
How many decimals?
2.
How many zeros?
2.
How many decimals?
3.
How many zeros? So look at the pattern, match it. Okay? So this one would be 3 and 16 over 100. So this one would need a denominator of 100. What's up?
How are you?
We're doing well, Ikema. How are you? You good? But you're not in class, so you're not that good. Always. See ya. Okay. So which one is larger? Well, we have no negative sign, so now this one's larger. Okay? No negative signs. Bigger numbers, larger. Yeah. Alright, so now we're going to compare. We have these two famous math words. They're cousins. What do they mean? What does they mean? What do they mean? Quiet man at the back, Joshua.
Ascending is going up, descending is going down.
That's right. So ascending is going from low numbers to high numbers. Okay, low to high. And then descending will be the opposite. Start with your high numbers, go to your low numbers. So what I want you to do is compare these and put them in ascending order. Always use the original. Okay. So I want you to compare them. Since I'm not telling you how to do it, so what would be the easiest way? Pinto? Put them all as decimals. What would be an alternate way? Fractions and getting a common denominator. Okay, so go ahead, use your decimals, because that's what I'm saying, do the easiest way. Go ahead, get your decimals. Use your calculator. Go. Plumber. Okay, so which one's the smallest? Negative 1.2. Then what do we have? Negative 8 over 7. Then the other one. Okay, so you gotta be careful with your negative numbers and go from there. Any questions?